Hi everyone, today we are going to go over the study guide for the 11.5 to 11.8 quiz. Find the following volumes. Let's look at number one. Number one, we notice that we have a box, and we know that the volume for any box is volume is equal to length times width times height. Now, since we're just multiplying these three numbers, it does not matter which number you use for each length. But we'll say that the length is 14 times the width, we'll call that one 9, and the height is 6. So when you plug this right into your calculator, you get 756. We're in inches, so inches cubed. Number two, we have a prism here, and we know that the volume of any prism is volume is equal to the area of the base times the height. Well, the base here is a triangle, because remember the sides of a prism are always the rectangles, and so the other shape that it could be for the base is a triangle. And we know that the area of a triangle is 1/2 times the base of the triangle times the height of the triangle. And then don't forget you have to multiply that by the height, that h there. All right, so we are looking at our triangle. We see that the base is 24 and the height is 18 of the triangle. So 1/2 times 24 times 18 times the height of our prism, which is 8. Plug that right into your calculator and you get 1,728. We are in centimeters, so centimeters cubed. For number three, we have a cylinder, and we know that the volume of a cylinder is pi times r squared, because the base of this is a circle, times the height. So I need to figure out what is the radius. Well, we notice that the radius is this here, which is 8, so pi times 8 squared times the height, and we know the height is here, and it tells us the height is 12. So we're going to plug this right into our calculator, and I would round to 2 decimal places. I will be sure to tell you exactly where to round on the quiz, but you get 2,412.74. We are in feet, so feet cubed. Number 4, we have a cone, and we know that the volume of a cone is 1/3 times pi times r squared times h. If we look at the base here, this circle, we notice that the radius is 30, so let's plug that in. I have 1/3 times pi times 30 squared, and the height of my cone is 50, so times 50. Plug that right into your calculator and you get 47,123.89. We are in meters cubed, so that's a pretty big cone. For number 5, we have a pyramid, and the volume of a pyramid is 1/3 times the base of the pyramid, sorry, that's a capital B, times the height of the pyramid. So step 1 is when we have pyramids, we need to figure out what shape is the base. Well, if you look closely, we see that the shape of the base is actually a square, and we know it's a square because those two sides are the same. So when we find the area of a square, we know we're doing length times height, so it would be 4 times 4 here. And then the height of this pyramid is 3, so multiply that by 3. Plug that right into your calculator, and we get 16 centimeters cubed. And for the last problem here, we have a cone once again. So we know that the volume of the cone is 1/3 times pi times r squared times the height. Well, we do know the height of this cone but we do not know the radius, and I'm going to call this x. So I need to solve for x here. Well, if I have a right triangle, I know one side and I know the angle, that means that I'm going to need to use trig. And since I know the opposite and adjacent side, I know I'm going to be using tangent. So tangent of our angle measure, which is 26, is equal to the opposite side, x, over the adjacent side, 22. I need to get x by itself, so I'm going to multiply by 22 on each side. So 22 times tangent of 26 is equal to x. Plug that right into your calculator, and we get approximately 10.73 is our radius. So now I have to plug this radius back into my volume formula. So I get 1/3 times pi times 10.73 squared times 22, which is my height. And when you plug that in your calculator, you get 2,652.47 feet cubed. Is the following a polyhedron? If yes, list out the number of faces, edges, and vertices. Then show Euler's formula. All right, so polyhedron. A polyhedron is just a solid that has polygon faces. So looking at A, is this a polyhedron? It is. Why? Well, all the faces are polygons. We see triangles and rectangles. So now that it is a polyhedron, let's list out the number of faces, edges, and vertices. And I'm not going to go into much detail as to how to find these. I think we've worked with this for a while now. So for A, faces, there are 5. Edges, there are 9. And vertices, those are just the corners, there are 6. Now we're going to check this using Euler's theorem or Euler's formula. And that is that faces plus vertices, sorry, it's messing up, is equal to edges plus 2. So when you are finding the faces, edges, and vertices, you can use Euler's formula to make sure that you count everything correctly. So let's check this. I know I would have 5 faces plus 6 vertices. Is that equal to 9 edges plus 2? And you'll see that it is. So we have everything correct. Let's look at B here. Is this a polyhedron? Yes or no? It is. All the faces are polygons. So yes. So let's find the number of faces, edges, and vertices. So there are 7 faces here, 15 edges, and 10 vertices. All right, so next I'm going to use Euler's formula to see if this all matches up. So is 7 plus 10 equal to 15 plus 2? And it is, so we know we are correct. In part C here, is this a polyhedron? The answer is no. Well, why is this not a polyhedron? One of our faces is a circle. Is a circle a polygon? It's not. So since it's no, I don't have to name out the number of faces or anything because it's not a polyhedron. Next, we're going to name the following polyhedron. So looking at our base here is how we're going to find out what to call this. So if I look here, I notice that this is 1, 2, 3, 4, 5 sides. So this is a pentagon. I also see that it comes to a point, meaning it's a pyramid. So this is a pentagonal pyramid. For part B, I have a prism, and I see that because it doesn't come to a point. So now I need to figure out what's the base of this prism, and it's a triangle. So this is a triangular prism. And the last one, C, once again, I notice that it comes to a point. So we have a pyramid. So let's look at the base here. It has 1, 2, 3, 4, 5, 6 sides. So this is a hexagonal pyramid. Number 9, find the radius of a cone that has a height of 15 centimeters and a volume of 450 centimeters cubed. So here's our volume equation for a cone. So let's plug in what we know. Well, we know the volume of our cone is 450. So 450 is equal to 1/3 times pi times r squared times, and the height is 15. So our goal here is to solve for r. All right. Well, I have this 1/3. And I'll kind of underline it, and 15. Since I'm multiplying, I can actually multiply 1/3 and 15 together, or 15 divided by 3. And we know that that simplifies to 5. So let's write that out, that 450 is equal to 5. And then we still have here the pi times r squared. So goal here is to get r by itself. So that means I'm going to divide by 5 pi because I need to get rid of that. Divide by 5 pi. Be careful when you plug this into your calculator. You'll want to make sure you put parentheses around 5 pi because if you don't, your calculator will do 450 divided by pi. I'm sorry, 450 divided by 5, and then times that number by pi. And we don't want that. We don't want that to happen. We want it 450 divided by the entire quantity, 5 pi. So try this because when you plug this in your calculator, you should get that 28.648 is equal to r squared. All right, well, we don't care about r squared, we care about r, so I need to square root each side, and when you do so, you get that r is equal to 5.35, and that's your answer. For number 10, find the side length of a cube that has a volume of 500 meters cubed. All right, so volume is equal to, if you have a cube, that means that all sides are the same. So normally with a box, it's length times width times height, but if they all are the same, we can actually just say, well, how about length to the third? Okay, so we know what the volume is. It's 500, so 500 is equal to our length cubed. So if I just want to figure out what is one side of the cube, I need to cube root this. All right, and so when you plug this in your calculator and you do the cubed root button, which you should practice, you end up getting that the length of the cube is 7.94. Number 11, find the height of this shape if the volume is 800 inches cubed. Looking at this shape, we know we have a cylinder, and we know that the volume of a cylinder is pi times r squared times the height. So volume is 800 is equal to pi times our radius, we do see is 4. So 4 squared times the height. So let's simplify this. We do know that 4 squared is 16. So 800 is equal to, and I'm just going to put the 16 first because it is multiplying. You can, flip things around. So 800 is equal to 16 pi. I want to solve for h, so I need to divide by 16 pi. Divide by 16 pi. Same thing, make sure you use the parentheses when you plug this into your calculator. And when you do that, you end up getting that 15.92 is equal to the height. Our last two problems here are about spheres. So number 12 says find the surface area of a sphere. So the equation for a sphere for surface area is equal to 4 times pi times r squared. Our radius we need to look for, and we notice that it's 13. So 4 times pi times 13 squared. You plug that right into your calculator, you get 2,123.72. We are in feet, and that is squared. And number 13, find the volume of a sphere. The volume of the sphere here is 4/3 times pi times r cubed. This one we have to be careful with because this would be our radius, but it tells us our diameter. So what is half of 12? It would be 6. So 4/3 times pi times 6 cubed. You plug that right into your calculator, and the volume would be 904.78 feet cubed.